So last time we stopped at 3.4, the slope of a line. So remember, the slope is the rise over run, right? Rise over run is for the slope. Now, if you always go from the left to the right to find the slope. So if you go from left to the right and take the rise over run, you see the slope is going up or down. Okay, so if you go from left to right and you are going up the hill, then your slope is increasing. You always go from left to right, so make sure that you read the slope as going from left to right. Now, if you go from left to right and you are going down the hill, your slope is decreasing. So the line goes up here, then the slope is positive. If the line goes down from left to right, then the slope is negative. The vertical line, if you have a vertical line, then the equation is x equal to a, and a is just some number, right? And because you have the vertical lines, then your slope is undefined. Imagine that if you are driving a car, if you driving up the hill, then you are going to a positive slope. If you are driving down the hill, then you are having a negative slope. But you can never just drive straight upward to the sky, right? There's no way that your car can drive like that. So therefore, the slope is undefined. However, if you are driving constantly at the same level of the route, then you have zero slope, or the equation is y equal to some number. I call that b, and your slope is 0. Now, just let's complete this table. If I have the vertical lines x equal a, and I have y 0, this is just some example, right? I just take 0 minus 1 or 1. Then your xy is a 0, a minus 1, and a 1. This tells me that no matter what value of y I pick, my x value is not changing. So this is y independent. I mean y independent. That means you are independent of the value of y that you are choosing. In the other case, this one, if I have 0 minus 1, this is just an example that I make up. B here, then your x is 0, b minus 1, xy, again just put in the xy coordinates, 1b. Then in this case, you are independent of the x, right? That means you are changing the value of x, but your y is not changing. Now, how do I find the slope by graphing? First, I can plot both of the point. So I stack the point to the left, and to get to the next point, I count up or I count down depending on the value they give us. Then I go to the right. Then so slope is just the rise over the run. And if you have to reduce the fraction, then you can do that. If you move up to get to the next point, the slope is positive because you are moving up to get to the next point. If you are moving down to get to the next point, then your slope is negative. Okay, let's try to find the slope here. Now 3 minus 4, so 3 is here, minus 4 is all the way here, right? And the other point is minus 1 and then 2. 1 and 2. Okay, so in order to go from this point we go from the left to the right. So we go from left, we hit this point first, and this point, go to this point, you have to go down and then go to the right. So go down, go to the right, and or it's rise over run. So you go down from 2, this is 2, this is 2, you go all the way to -4. That means you go down by -6. You go down -6, and you go to the right by 2 units. Let's see. No, it's not 2. Oh, sorry, this is -1, not 1. So -1 is here. So -1 and 2 is here. So you go down here. Let's erase this. This is not. Yep. Okay. So -1 and 2 is here, and this is 3 minus 4. So you go down from -1 to -4. That's -6. No, sorry. That's from 2 to -4. So you are going down 6 units or -6, and then you go from here to here another 4 more units. So -6 over 4 or -3 over 2. And the same thing to this example 2. I have the first point is -5 here and -8, so it should be here, right? And -3, -3, -3 here, -3 is here. So you can also use the slope formula x1, y1, and then x2, y2. The slope formula, remember, was y2 minus y1 over x2 minus x1, and y2 now is -3 minus y1 is -8, x2 is -3 minus x1 is -5. So that's become +8. So on the top I have 5, at the bottom I have 2. Slope is 5 over 2. So the easier way is you use the slope formula for the point x1, y1, x2, y2. This is again just the review. So you have y2 minus y1 over x2 minus x1. And again, this is extra example for finding the slope. So this is your x1, y1, this is x2, y2, and your slope is y2 minus y1 x over x2, which is -3 over minus of x1, which is 4, and you should get -7 over -7 to be 1. Right. The same thing here, you can do this by yourself, and the answer is -1 over 5. Okay. Now you can find the slope and the y-intercept, right? And remember, the slope-intercept form is y equal mx plus b. M is the slope, b is the y-intercept. So this form is already in the form of mx plus b. So the number in front of the x is the m, or the slope. So the slope is just -2 over 7. Y-intercept is -6, or you can rewrite in the order pairs 0 and -6 here. This one is already in this form too. So 8 is the m, or the slope, and 10 is the y-intercept, or 0 and 10. This one is not. First is you have to solve for y, because you want to solve for y on the left side and the rest to the right side in order to get to this form. And you can do that by moving -3x to the right hand side. So I have y -2y equal -3x plus 10. I divide both sides by -2. right? I get y to be 3 over 2x minus 5, and this number here is a slope or m, and this one is a y-intercept or 0 and minus 5. And you can do the same thing to this number 4 as number 3, and you get y to be minus 3 over 4 x minus 3, and the number in front of the x variable is just the m or the slope, and minus 3 is the y-intercept or 0 minus 3. Okay, how do I graph the following lines on the xy axis? You can graph this easily. So first, using the y-intercept, this is 7. So I plot the 7 on the y in the y-axis first. Now minus 3 for the slope. Minus 3, you can rewrite this as minus 3 over 1, the same thing, right? For the slope. That means from this point, you going down 3 units, and then you go to the right by 1. Minus, you are going down, and you go to the right by 1, and then you connect the point, and this is your line. But let me redraw this one here to make it look better. So something like that. Okay. Now the second one, I don't have any number here. That means I have the 0 for y-intercept, and again minus 3 equal minus 3 over 1. You go down 3 units, you go to the right by 1, plot the point, and then connect them together. This one I have minus 5 for y-intercept, again minus 3 for the slope, go down 3 to the right by 1, and then connect the point. Okay, and it looks like that these 3 lines, they are parallel, right? If you draw carefully, then you can see that they are parallel, and they are parallels because they have the same slope. So any slope that are equal, they are parallel. Okay, how about these two? So parallel meaning that we have the same slope. Now for these two, let me graph them first. So minus 2 for the y-intercept. Slope is 1 over 3. So I go up 1, go to the right by 3. So I have my first line. Now this one is 1, it's here. Minus 3, which is minus 3 over 1, right? So I go down by 3, go to the right by 1, which is this point, and now I connect them together. And this looks like that they are not parallel, but they are perpendicular because they make the angle of 90 degrees. And in this case, if you notice that the slope, this is 1 over 3, but this one is 3 over 1, but there's a minus. So these two lines are called perpendicular because they have opposite reciprocal slope. That means their slope are opposite with the side, and they are reciprocal. That means one is the flip of the other one. So they are opposite reciprocal slope, and they are perpendicular. So remember, if you have the same slope, they are parallel. If they have opposite reciprocal, they are perpendicular. So again, slope, parallel line, they are the same, and perpendicular, they are opposite and reciprocal. Okay. Okay, let's see what is slope of a line parallel and perpendicular to the given line. Now, this line, we have the slope is 7. Now, the slope of the line that is parallel to this line, parallel that means it should have the same slope. And the line that are perpendicular, we have the negative or opposite of this side, and we take the reciprocal of that. So this is 7 over 1, this is 1 over 7 with a minus for perpendicular. This one, y equal 10, that means the slope is 0 because this is the horizontal line, right? And the parallel, we have for the parallel, we have the same slope, which is 0. However, for the slope with the perpendicular, the slope of a line that is perpendicular, we have the negative reciprocal of that. But then this is 0 over 1, and for the perpendicular case, we take 1 over 0. And you cannot divide by 0, so this is undefined. So in this case, for this horizontal line, we don't have the slope of the perpendicular line, or it is undefined. Now let's try this problem. This one, x is minus 12. X minus 12 is just the vertical line, right? Vertical line. Now, the slope of this vertical line is undefined, and the slope of the parallel to this line is also equal to this one, or also undefined. And the slope with perpendicular, because this one undefined, that means it's divided by a 0, so it's undefined. And this one is the opposite of that, or 0 over 1, and negative is still the same thing, or you have 0. So in this case, the slope of the line that is perpendicular to this line is actually 0, even if the original line is undefined, because this is vertical. Now, this number 2, you can try on your own, and the answer should be, so this 2/5 is the original slope, and the one parallel to that, the same thing, and the one with perpendicular, you have minus 5 over 2. Okay, so now we have the set of question here, and they want to compare these two equations, whether they are parallel, they are perpendicular, or neither. So in order to see if they are parallel, perpendicular, you must find the slope and compare them. If the slopes are equal, they are parallel. If the slopes are negative reciprocal of each other, then they are perpendicular. And if they are not anything of these two, then they are not parallel or perpendicular, or neither. Let's try the first case. This one, I have the slope is the one standing in front of the x term, or to be 4. This one, I have minus 4, because 4 and minus 4, they don't have anything. They are not the same. They are not negative reciprocal. So this case is neither. This one, I have the slope it to be minus 6, and this one, the slope is the one in front of x, which is 1/6, right? And if you notice here, minus 6 is actually minus 6 over 1, and then now if you flip that, it becomes 1 over 6, and you take the minus of that, would become the positive. So they are negative reciprocal, which is perpendicular. Now in this case, I have the slope of the first line to be 2, 4, and this line to be 1, 2. 2, 4, I can reduce this to be 1/2, and 1/2 and 1/2 are equal. So same slope, they are parallel, right? And this one, the first one, it's 1/2. The second one is 2. So even though 1/2 and 2 they are reciprocal of each other, but then they don't have the opposite side. Because they don't have the opposite side, they are neither, because you need the opposite reciprocal. This one is only reciprocal but not opposite. They need to have the opposite side. So one positive, one was negative. So that is section 3.4. Now we are moving up to section 3.5, equation of the line. Okay, so we are trying to write the equation of a line given any point and a slope, and we call that the point-slope formula, because we are given a point and a slope, then we can have the point-slope formula. So I call the point x1, y1. So the point-slope formula saying that y minus y1 equal m, the slope, multiplied by x minus x1. This is just another review. So let's try the first one. We are given a point, and I call this point to be x1, y1. Slope now is called m. Now the equation is what? Y minus y1 equal m x minus x1. Y minus y1, which is 10, m is 1/3, x minus x1 is minus 3. So y minus 10 equal 1/3, x plus 3, because minus of minus. Now I do the distribution of 1/3 to the inside here. I get y minus 10 equal 1/3 x plus 1. And then I move the minus 10 plus 10 on both sides. I have y equal 1/3 x plus 11. And this is the equation. At this point, we have the slope, we have the point, so you should do the same thing here, and you can do it by yourself and check the answer to be y equal minus 4x plus 1. The same thing to here, the same formula, and you can check the answer to be minus 1/2 x minus 5. And for this one, that's right, we are given the slope to be undefined. So if you have undefined slope, that means the line is vertical, right? That means it's just crossing through the x value, and we have the x value to be minus 2. So you just have x equal minus 2 is the line. It's just crossing through the line of minus 2, right? This one. This is a line. Vertical, undefined slope, and it's crossing through the x equal 2, because you have the point minus 2 minus 5 to be the point on the line. Okay, to find the equation of a line, if you are given 2 points. If you are given 2 points, then you can find the slope first, and then you use the point slope formula to find the line. So let's try this one. We have 4 different examples, but they are similar. So let's try one of them. Let's just pick this one, right? So I picked number 2. So I picked this one. I call this to be x1, y1, and this is x2, y2. Remember, if you are given 2 points, then first label them with x1, y1, x2, y2, and then use the slope formula. M equal y2 minus y1 over x2 minus x1 to find the slope first, because you are not given the slope in this case. And I have what? 0 minus y1 is minus 8 over x2, 2 minus x1, which is minus 1. I have 8 over 3 for the slope, or m. Now I use the slope formula, point slope formula. Y minus y1 equal m x minus x1, and then y minus y1, which is minus 8, equal m, or 8 over 3 x minus x1, which is minus 1. So minus minus become plus. Do the distribution here. Have a over 3x, and then this is plus. So plus a over 3. Now I subtract a on both sides. I want to solve for y. I got y to be a over 3x minus 16 over 3. And you are doing the same thing to the other three problems. First label them and then find a slope and use the point slope formula. And if you do this correctly, you should get here to be y equal minus 3, and here you should get y equal minus 1/2 x plus 4. This is y equal 3x plus 6. So try this on your own, and we can go over it together if you still have the wrong answer when we are back to the class. Okay, so the next topic is finding the equation of a line given a point and a line parallel or perpendicular. So if you are given a line and you are saying that this line is parallel to the given line with a point or perpendicular to the given line with a point, then you can find that. So in order to write the equation, you need two things: the slope and a point. Now you already given a point. Now just find the slope. If they said that that line is parallel, that means you have the same slope. If they said that that line is perpendicular, then you have the slope to be the negative reciprocal of that. So let's try these two problems. So they said that you have the parallel line to this line, and you are crossing through this point. Because you are parallel to this line, that means you have the same slope with this line, or the slope to be 1/5, because the slope of this one is 1/5. Now you have the slope. You can find the line by using the point slope formula, and I call this to be x1, y1. So I write y minus y1 equal m, x minus x1, y minus y1 to be 2, m is 1/5, and x1 is 10, right? So for y, make the distribution of 1/5 to inside first. This become plus, so you have 2, and then I plot 2 on both sides. I have y to be 1/5 x plus 4, and for this line we are given the point, and also they said that it's perpendicular to this line. So now this line has a slope of 9, but the line we are finding is perpendicular. That means it has a slope of the opposite reciprocal of that, or minus 1/9. And if you are doing the same thing here, you do y minus this x1, y1, y minus y1 equal m, x minus x1, 2 equal minus 1/9, x minus 27. And if you do this correctly, you should get y equal minus 1/9 x minus 1. The last section to review in this chapter is section 3.7 in the notes or graphing of linear inequalities. Now, inequalities represented by the symbol of less than, bigger than, or with an equal sign, right? If you don't have the equal sign, then you can use a dashed line. If the inequality does including the equal sign, then you have to use the solid or the solid line without the dash in between. Now this is the step for graphing a linear inequality in two variables. The first thing is you have to replace the inequality sign with an equal sign, and you can write them in the format of y equal mx plus b. Then you graph the equation. Now next is you choose or pick a test point that is not on the boundary, the points are not on the equation of the line. Now sub that point back to the original inequality. After you pick a test point, then sub that back in the original inequality. Now if the statement is true, then that is the region of your solution, or you have to say the half plane that contains the test point. If the statement is false, then you say the half plane that does not contain the test point. I believe you learned this from Math 20. So now let's try a few problems. So let's look at this inequality. The first is, I know that this does not include the equal sign, so the line must be a dashed line, right? So step 1, I rewrite this inequality by the equal sign. So inequality become equal sign. 2x minus y equals 6. And now I can just graph this equation. This is easy. I can pick 2 points and then plot them. The first point I have 2x to be 0, and if x is 0, y minus 6, right? The second point, if I 2x to be 3, then my y should be 0. So I plot those 2 points, 0 and minus 6 here, and then 3, 0 is here, and then I connect the point. And make sure, because this does not include the equal sign, you have to use the dash, not solid. Okay. Now there are 2 regions, this plane or the other half plane. So let's pick a test point. So maybe I pick this one because this one is not on the boundary. So this point is 0, 0, right? The test point. So step 2, I pick the test point to be 0, 0. I plug back into the original inequality. X is 0, y 0. So I have 2 times 0 minus 0. And does this one less than 6? The answer is 0, less than 6. So yes, this is true. So I say the half plane that contains the test point. Okay, so that is the solution. So the solution is this half plane. Okay, so let's try the last 3 examples here. Because we have the OR, that means this represents for the union, right? So this one or this one. So let's do individual inequality first. So let's take care of the first one. So the first one, 2x minus y equal 3, step 1, right? And then I pick 2 points to draw the plane, I mean the equation. So I pick 3 half, I got y to be 0, or I pick 0 and minus 3. So 3 half is here, and 0, right? 3 half is here, around here, and 0. and 0 and -3, which is here. And because this one does not contain the equal sign, so again, this is the dashed line. Now I can also pick 0, 0 for the test point, and 0, 0 turn out to be true. Wait, hold on. 0 for x, so 2 times 0 minus 0 for y. No, 0 less than 3 is 4. This is not true. This is 4. So that means this region is not a solution. I shade the other one, the other region. Here. Okay. Now x bigger than 0. So x equals 0 is this line, right? Also the dashed line because there's no equal. So bigger than 0 is the whole thing to the right of that. So the solution, that means or is the union. That means all the region of the two inequality, or the whole thing. So this region, and this region, right? These three are the solution. So the whole thing here, the whole thing here, the whole thing here, and the whole thing here, they are all the solution. Because the union, that means we take all the region of the inequality to be the solution. Now, and the n words represent for the intersection. X bigger than -2, so -2 is here. So x bigger than that, or all the way to the right. We are using the dashed line because no equal sign. Now 3 is here, and we are using solid that line because there's an equal sign. Now less than 3, or from here we draw all the way to, we shade all the region to the left side. Now the intersection of these two is the one here, right? They're overlapping here. So this region here is the solution of this example. And this one, this is similar to this problem, so you can try this on your own for practice, and we can compare the solution when we get back to the class for this one. Alright, so that is the end of chapter 3 for this video.